Hello? Hello?
Hello, I am waiting for a while, please. Mr. Tajim Niamatullah Akund is here. Thomas, Mr. Thomas Zakas.
Sorry.
Tanjina Helali. Tanjina
Yes.
Helali. Okay.
Yes, I'm here.
Tanjina Helali, you can start your presentation. Welcome. Please share your screen.
Yes, I'm here. Just a second. So can you see my screen?
Yes, we can see.
So
Please,
hello everybody.
please
Yes,
don't use full screen mode.
Oh, okay.
Okay. Okay.
So this one is okay?
Yes, yes.
So hello everybody, I'm Tanzina Hilali from Bangladesh, and I'm going to present the paper, A Greedy Graph-Based Character Segmentation System for Bangladeshi License Plate. And there are two more authors in this paper, Rashik Rahman and Tanmoy Sarkar Pierce, and all of us are from the University of Asia Pacific, Bangladesh. So these are the content of our presentation. First, a brief introduction, then the Bangladeshi license plate features, the data set we are using, some of the existing methodology for segmentation, our proposed methodology and algorithm, then result and conclusion. So I'll start with a picture of our traffic, regular traffic every day. As you can see, this is a crowded traffic area, and this is our daily traffic. Actually, this is not a peak hour traffic. This is our daily traffic. So for Bangladeshi traffic system to manage the traffic is very hard. The service they are providing to manually plan everything, to manually manage everything is very hard. So for Bangladesh is in great need of having an intelligent traffic management system. And then the center of the intelligent traffic management system is the automatic license plate recognition. So license plate recognition system consists of three phases. The first one is license plate detection, which basically locate the license plate in an image, and then license plate segmentation, which separate out the characters in the license plate, and then license plate recognition, which is the final step. Here we recognize the characters in the license plate. So for an effective recognition system, detection and segmentation is also important. Without efficient detection and segmentation, we cannot have an efficient recognition. So in our paper, we propose a simple but efficient and computationally light graph-based greedy algorithm that doesn't require any expensive or high configuration computational system. So this is an image of our license plate. So different countries have different format in their license plate. And like all other countries, we have two types of vehicle, private and public. And then the license plate of those are different. One has green background, whereas the other has white. And then the image in the bottom, you see there are two rows in our license plate. The top rows consist of the alpha characters, which has some meaning in it. And then the bottom row has 6 numbers. And all those are Bangla characters. So in the top row, the first part represents the city name. The second segment is the metropolitan text, and then the third segment, which is a single character, is the vehicle category. In the bottom row, the first 2 numbers represent the class, and the last 4 numbers represent the vehicle number. So for our research, we created a new data set because the existing data set we have, all those have kind of near perfect images and little bit variation, but in real life, as the picture will be taken from the surveillance camera, it is hard to get a real perfect image. It will be slightly tilted or rotated or in low resolution. So here we have some sample of the data set we created, and we collected 2,000 images for both public and private transport, and at different scenarios, different lighting condition and different tilted version. So these are some sample images from our data set. So there are already research going on for automatic license plate recognition, and as part of that segmentation, these are the few existing methodology: hog classifier, template matching, local binary pattern, and then some neural network based methodology, and connected component, which is a generalized version, and OpenCV. And all those methodologies are like complex, computationally expensive, and most of them work on the perfect image, and with a little variation, but the system we develop can actually segment lots of variety of images. So this is our proposed methodology. We take an input image, which is a 24-bit RGB image. Then we convert it to 8-bit grayscale image. Then we convert it to a binary image using an adaptive threshold technique, which will map the image to two different values, 0 and 255, where 0 represent the black pixel and 255 represent the white pixel. So to improve the storage efficiency, we then map those two values to 1 and 0. So 0 maps to 1, then 1 will represent the black pixel, and 255 maps to 0, which will represent white pixel. And that at step 4, we do the segmentation, which is a modified version of BFS traversal algorithm. So here is the complete algorithm we used for our research. So from 1 to 5, I already described in the previous slide. From 6 to I think 19, this is the modified version of BFS algorithm. So in the left side, we have two pictures. The top one is the binary image, which is the number in black, and then the white background. And the bottom one is a two-dimensional matrix, which has the mapping 0 to 1. So from in this algorithm, we will basically scan this matrix from top to bottom and left to right. So basically, we'll scan column by column, and we stop at a position where we'll find a 1, which will represent a black pixel in our original image, which is basically this point. And there we'll apply the BFS algorithm. So we'll try to we'll find all the neighbors that are black and not yet visited. So here we use the BFS. So all the BFS terms like visited pixel, then the NQ, DQ, all those are here. So I'm not going to the details of that one, just in the high level. So once we get all the neighbors that are not yet visited but blacks, that means those are part of a character because these are black. For each of the neighbor, we'll do the same thing. That means we'll find the neighbors that are not visited yet but black. So we'll keep the process running until a point where we'll not get any black neighbors. So in the upper picture, if I can do the same thing, once we get, first we'll find this red pixel here, and then we'll identify the black neighbors, which are these 3 pixels, and we mark those as red because those we already visited. And for each of these pixels, we'll try to identify the neighbors that are not visited. So for the first one, there will be no neighbor. Second one, no neighbor. For the third one, we'll find these 3 black neighbors. And then we'll do the same thing for these 3 black neighbors, and there is no neighbors that are not visited yet. So along in this process, we'll also keep the row and column of each of the pixel we visited and marked as visited. So from those 2 array, we'll get the minimum row and minimum column, which will represent the upper left corner of a segment, and then the maximum row and maximum column, which will represent the bottom right corner of a character or segment. So using these 2 points, we can easily isolate a character from the license plate. So we'll scan the whole matrix and we'll keep all those minimum row, maximum column, all those information in an array. And at the very end, using those information, we'll crop the characters from the original image. So we ran our algorithm against those 2000 images we collected from the roadside, and we're successfully segment 1990 images. And here are some of the results, and our result actually is much better than all of the existing algorithm we studied so far. So this is a result of a good image, which is like no rotation, no tilting, those kind of thing. So first one is the original image. This is the binary version of the image. And after segmentation, we find these are the characters. If you notice, the top part, which are the characters, are there. So this part, the metropolitan, and then the last one, and then the numbers are also there. Like this is the first number, this is the second, then the next 3, and the 4th one. Even though it looks like they are mingled, but if you notice, the character relative sequence and then the relative sequence of the numbers are preserved. So by applying a deep learning algorithm, we can easily locate or segment those characters from the license. So we also try with different variation of the image, like here, the license plate are rotated. The first one is 50-degree rotated. Second was 90-degree rotated, but our algorithm was able to segment all the characters from the license plate. So these are horizontal tilt image, vertical tilt image, and we tried at different angle. So from 0 to 85 and up to 82 degree, where 100% successfully segment all the characters. Above 82 degree, we had some failure, but up to 82 degree, we are 100% successful. And the state of the art algorithm currently we have that we're able to segment up to 75 degrees. So our algorithm is outperformed the state of the art algorithm. We also apply the algorithm on full-scale image and was able to segment the license plate, but here we had to do some manual cleaning, the noise removal, we have to do it, otherwise it was hard. So we have future plan to improve this algorithm so that we can do it automatically. So our main contribution here, we introduced a greedy graph-based character segmentation algorithm that can segment the license plate of Bangladeshi vehicle, but I think it will also segment the other characters as well. This algorithm can segment the license plate from a rotated image up to 360 degree. The existing algorithm can go up to 20 degree, but our algorithm can go up to 360 degree. But I think after 90 degree, the relative sequencing may differ, but we can segment. A horizontally tilted image up to 85 degree and vertically tilted image up to 84 degree. And this algorithm can be used to segment any connected components from an image. So our plan as a future work to remove the noise automatically In the license plate, if there is any dart or anything hanging around, because sometimes the license plate is not that clear, so our algorithm will not perform better in those cases. So we have planned to improve that so that we can automatically remove the noises and segment the characters. Then second one, if any character is broken due to poor image quality, our algorithm will fail there. It will identify one character as true maybe. So we have planned to improve that. And the third one is, during the binarization process, we used an adaptive threshold. So we'll investigate there, put some extra effort so that we can improve the segmentation for the blurry images. So lastly, we want to thank the Institute of Energy, Environment, Research and Development of UAP for their financial support. Thank you everybody for listening. If you have any questions.
Thanks you for your presentation. Dear participants, do you have any question about this article? Okay. I wish you continued success in your career. Hope to see you, Mrs. Tanjiya Helali.
Thank you.
Thank you. The other presentation. Selma Abdullah Aswat is here. Tanmoy Sarkar Pias. Are you ready? Tanmoy Sarkar Pias.
Hello, can you hear me?
Okay.
Okay, so I will present my paper.
You can start your presentation. I make you host role.
Okay, thank you. Let me share my screen.
Okay. Please don't use full screen mode, and you have 10 minutes. Okay.
So I'm not going to use the full screen mode, right?
Okay.
Okay.
Yes.
Is this okay?
Yes.
Okay. So I'm Tanmoy Sarkar Pias. I'm going to present deep learning based Bangladeshi license plate recognition system. Our paper ID is 227. I'm presenting on 4th International Symposium on Multidisciplinary Studies and Innovation Technologies 2020. I am from Computer Science and Engineering Department, University of Asia. There are 4 other authors in this paper: MD Misbah Sharif, Tanjiya Helali, who already presented a paper, MD Shohel Rana Tutul, MD Naimur Rahman. All of us are from Department of Computer Science and Engineering, University of Asia. So we segmented our presentation into these sections. At first, we will go to the introduction, then we will state some problems in the current system, then we will state our research statement, then we will give an overview of our Bangladeshi license plate, then we will review the latest work in this field, then we will propose our algorithm, and we will discuss in detail. Then most important part, the
Please volume up, Mr. Tam Sarkar.
He is muted.
Okay, is everything clear now?
Okay.
Okay.
Yes, you can continue.
Okay, thank you. So the question is, what is deep learning based Bangladeshi license plate recognition system? So it is a system, or it is an approach which can automatically recognize a license plate from real-time video. So why do we need this system? In brief, we can say that if we want to build a smart city, we need this system. So if we see that there is a lot of traffic in the road, because Dhaka is a mega city of the world, and there is a lot of traffic all the time in the road. So we need a smart solution, smart approach to manage these traffics. The first step to solve this traffic is to implement an real-time automated license recognition system or license plate recognition. So we have found three major problems: manual control, traffic control, poor maintenance in toll plaza, poor surveillance in car park. So this is our research statement. A fully automated license plate recognition system using surveillance camera in a real world scenario. We have implemented this for Bangladesh right now, but can be implemented for any country with a simple modification. This is the overview of our license plate. One of my colleagues already reviewed this, so I'm not going into the details. So this is the important part. Literature review who work in this field and got implemented this type of systems. At first, we can see that automatic license plate recognition for Bangladeshi vehicles, it got 80% of accuracy, recognition accuracy. Second was is also like similar. It used artificial neural network and got 84% accuracy. Third one has implemented the detection and recognition part. They implemented both sections and got 84% accuracy. Fourth one used CNN for recognition only, and they got 88% accuracy. The fifth one is interesting. They used YOLO for three stages. Like we have three stages. Like one is detection, second is segmentation, and third is recognition. So they have used only YOLO for all the three segments, and they got 92% accuracy. And they introduced a data set consisting of 1500 images. The sixth one, which is the major, which is the highest accuracy of them all, and but this is only for recognition accuracy. They their major contribution is in the recognition part, and they introduced a data set with 2800 images, and they got 97.3% of recognition accuracy. So we have found three major problems from these previous studies. First problem is there is no real-time system. Second, lack of end-to-end system. There might be one, but they don't perform that really well, and their performance degrades in the real-world scenario. So we address these three problems from studying the state of the art or the recent studies in this field. So we want to solve these three problems and want to implement an end-to-end system in the Bangladeshi streets in the surveillance camera to automate the process. So this is our proposed technique. We feed the real-time video and we use YOLO detection process to detect the license plate, and it segments the license plate from the video and gives it to the next stage. In the next stage, we use the segmentation algorithm. The segmentation algorithm we are using, my fellow colleague already discussed about the segmentation algorithm. That algorithm we are using here to build the total model or complete model. And after segmenting the characters, we pass it to the CNN model for recognition. Then we get a recognized license. So this is our overall technique or proposed technique. For that, we introduced a dataset of 2000 images, and we collected a diverse dataset to capture most of the real life scenarios which occur in the streets. And for segmentation, we didn't use any machine learning algorithm. We used a graph-based algorithm. So there is no training or testing part. We used 200 images to test how it performs. And in the recognition, we use a subset of the main dataset for recognition, for recognizing the characters. So this is the example of our example images from the dataset we are using. The first one is captured with a low resolution mobile phone or smartphone. The second one, most of the images in our dataset is in form of second one because we implemented our camera where a surveillance camera can be installed. And the third one we can see it is in the night. So we have captured many nighttime images. Fourth one is in the garage or in the parking site. Fifth one is also in the parking site, but very low amount of light, insufficient light. So we try to, there are many more variants. We just highlighted these 5 to represent our diversity of our data set. So there are some more. Okay, so we can divide our process into 3 steps: first detection, segmentation, and recognition. So in detection, we used YOLO version 3. While we were working in this research, YOLO version 3 was the state of the art. So that's why we used YOLO version 3, and it is real time. So we can implement this total system in the real time with this YOLO version 3. And this is the training specification of YOLO version 3. I'm not going into the details because there is nothing much to say about it. But the important thing is we use 2,000 images to train this model. This is the output. By after training, we can see that it can segment the license plate very clearly. In the second image, we can see that third license plate is much more unclear. But the thing is, this issue can be solved because that red vehicle already passed through the surveillance camera, so it was near at some point. So that time we can segment this license plate and get a more resoluted image. Or other approach can be that if we install a more robust camera or more expensive or more good camera to get a good picture. So there are some other output. The first one was taken from another vehicle. So this implementation means police or the law enforcement can install a camera in front of their vehicle to detect the license plate. Second one represents from the footpath where a surveillance camera can be installed. Third one is from the foot over bridge where another camera can be installed. Fourth one is in the shadow place, so where the sunlight is insufficient. So we try to capture the real life scenarios that happen. Then go to the segmentation process. In the segmentation process, my colleague already discussed about this thoroughly, so I am going to just brief. In the segmentation process, we used a greedy graph-based segmentation technique to segment the characters from the license plate. There are 4 stages. In the fourth stage, we get the segmented characters. This is the mapping. Is actually work on BFS. So this is a modified version of BFS and a modified version of connected components actually. But the segmentation can be done by other implementation also, but their complexity is huge. But this is very simple and lightweight segmentation process. So this is the result of segmentation. After segmentation, we pass all the segmented images to the convolutional neural network, and we generate the dataset from the segmentation stage. So this is the overview of our recognition dataset, and all the classes are here, and we use a good amount of images to get better rank. And this is the CNN model we have used in our study. This is a vanilla and very simple CNN model, only has 4 layers. We could have used more complex implementation of CNN like ResNet or ImageNet. We already did and saw that there was not much improvement of the accuracy because the dataset, the recognition dataset is not that much complex. Because I can say that most of us know the MNIST dataset and written recognition dataset. They have 10 classes. Our dataset is similar to that and have 30 classes. So we don't need a complex model to recognize the segment. So this is the results after detection and recognition. We got 92% of accuracy in the detection part and 97.5% of accuracy in the recognition part. And this is the highest accuracy in this field. And our data set is very much diverse, and so that we can say that this is the latest progress in this field. So our contribution, if we summarize, this is a real-time system, end-to-end system, relatively faster than existing system, and we can capture license plate in different angles. We can capture multiple license plate from one images. And license, if the vehicle is far away or far in distance, then we can also capture that with a highly resoluted camera. And we also introduce most of the natural condition of light to get a diverse data. So these are the major contribution in this research. And based on this research, we can add more images like to capture the effect of climates such as rainy, foggy, and hazy. And we can also add the images of speedy vehicle when the license plate is blurry, and the license plate can be occluded by another vehicle that can be reconstructed. And of course, we can always increase the efficiency and accuracy of the model. So this is the future work based on our model. And in the application, we can say that in the first step is to identify the vehicle. We can automate the toll plaza, automate the parking, and we can also introduce it to the law enforcement to build a secure smart city. And we would like to thank the Institute of Energy, Environment Research and Development and the University of Asia Pacific for financial support. So thank you, and thanks to the references, they helped us to build this system. And thank you. This was all. And is there any question you may ask?
Thank you very much for your presentation. Dear participants, do you have any question about this article? Okay, no question. I wish you continued success in your career. Hope to see you.
Thank you. Thank you very much.
Mrs. Filiz Aslanable,
Yes.
are you ready?
Yes, I am ready.
Okay. You can start, please.
Okay. Not
you
full
have
note. Okay.
You have 10 minutes, please. You have 10
Okay.
minutes.
Okay, I have 10 minutes. Okay. Thank you very much. I am Filiz Alshanable. I am from nearest University of Northern Cyprus, north part. I'm in Material Science and Technology Engineering Department, assistant professor, and my colleagues are all mechanical engineering, my previous department, which is mechanical engineering department. Okay. This is a part of study that we are going to use potential use of jojoba oil in the island and jojoba oil extraction process. This time we are going to model the process is going to be modeled by fuzzy logic system. I have a quick start to introduce what is jojoba plant and what is the use in the Cyprus. It is identified in 1989 and it is first grown in Arizona deserts. It is evergreen all the seasons and it has minimum water requirement and it can survive even in the deserts condition. 200 years of lifetime and it has female and male plants. It is actually it is not a trees, it's a shrubs. And its seeds, which we are interested in, is this is the fresh one, is we let them to dry and we're using. Its seeds contain oil of about 50% by weight, which is twice the amount of soybeans and 3 times the olives. Okay, this is the Cyprus island. This is the northern part, Turkish part, and what we call Masario Plain is the huge area, approximately 20,000 of hectares. Within this area, it is between the two big cities, which is the Nicosia and Famagusta. Within this area, only a small area which is 150 dekar. It is approximately, it is equal to 15 hectare out of 20,000 hectares we can use it. It was planted by jojoba 2004. The aim was only for testing, but from that time it's just stay as it is. I want to understand the process which we are modeling. I want to talk about the jojoba extraction process. We have nursery first of all from the seeds. We are growing up the fresh plants. Then plantation is going to be occur, taking care about the female and male plants, and then after harvesting, oil extraction process. We are using here mechanical grading process, mechanical extraction process. The raw jojoba oil is then filtering, and the jojoba oil is going to be used for many purposes. It has added values to economic of the countries. The potential use of jojoba oil is the large area of the potential use is in the cosmetic areas like hair oil, shampoos, soaps, and cosmetic purposes. The second important part is in lubrication. Lubrication, it is better lubricating than the whale oil, sperm whale, and pharmacologics, polishing and waxes, protective coatings, and food-related use because it has no shelf life, no limited shelf lives, and so on. One of the important usage for our universities working on it, work on it, it was production of biodiesel. We suppose that we can produce in biodiesel production, we were sufficient, but actually it is not oil like other plant oil. It is a wax form. So a production of biodiesel now is our second or third option. So aim of the present study, actually this study is the continuation of the more larger research related to characterization and the usage of the jojoba oil. We are just aiming, in the case of possible jojoba agriculture and industry, to develop this one in the region. We are just optimizing oil extraction parameters for maximum oil yield to obtain the maximum oil yield. And this goal, optimization process, could be achieved by developing fuzzy logic model. Previously, we were done this by using Taguchi analysis. In Taguchi analysis, for example, we were reducing process conditions, the experiments we are able to produce with optimum process conditions. An application of fuzzy logic system has been developed in this work and to model the process parameters of extraction of jojoba oil by screw expelling of the jojoba seeds harvested from Massaria plain. Yes, those are the jojoba seeds, and these are the oils extracted as a result from the seeds. Okay, we are using for modeling, we are using fuzzy logic. It is the huge development in the machine learning technologies. It is imitating the logic of the human thoughts, and it is representing the values. Actually, it is representing the gray part of the thinking system, like human is thinking about the project, about the problems. Fuzzy logic modeling, basically taking a step in the three parts. Here we have added the fourth part. Actually, it could be 5 parts because selection of the process parameters. It is fuzzification, fuzzy inference system. Everything is we are going to perform here, the process, and the fuzzification. Now, fuzzification and defuzzification is opposite processes, and I'm going to summarize the things here. You're taking the crisp input data, you are choosing those data, input variables, and already those experiment is done with some input parameters, and we obtain some yield, and we are going to see that if fuzzy can be modeled, and if with the unseen data, if he is going to find the output, if he is going to predict correctly output or not. So it is in 3 parts. It is a knowledge-based learning, but at the same time, it is supervised learning. I mean, every part of the in fuzzy system, you are designing whether you're using some soft computing techniques or not, you are the one choosing the system. You are converting the crisp input to fuzzified input. So how we are doing this? We are doing this by using some membership functions. After fuzzification is going to be occurred, then we are going to use fuzzy inference engine. In this engine, we are writing some rules. It depends on our input data and output relation. We are teaching the computer how to think, what is the relation between input and output, which is usually we are using fuzzy logic for non-linear relation. Then after fuzzy inference system is calculating, and you have going to obtain the crisp output data of your system by this fuzzification process, you are checking the error. If it is smaller, it's okay, your system is working. Otherwise, you're turning and you are considering the membership functions. Here, the selection of oil extraction process parameters. We are choosing, like our previous work, it was already chosen. Each parameters we use for parameters, seed size, seed humidity, size I have illustrated in this picture, and this is the machine we have designed. And process temperature, process pressure, and each parameter has 3 levels, only 3 levels. But we perform 27 experiments, and within this 27 experiment, we have performed actually only 9 experiments. It is only 3 repetition of each of them. Now, seed size, this is our process optimization process model. It is run by the Matlab, and it is seed size. You have seed size, seed humidity, seed temperatures, residual discharge opening is chosen as a process parameters, input, and extraction yield. To maximize the extraction yield, we are looking for the conditions of the input parameters. In fuzzification step, in the first step, the data we have using numerical values. If some verbal values like a whole, we have convert them into a number like 1, 0.1, 0.25, and so on. Then those numerical value we have put in the linguistic term. For example, for seed size, we have used quarter, half, and whole terms. And for seed humidity, very low humidity, medium, and high humidity we have used. And we have used for seed temperature, low, medium, and high. And residual discharge opening, we have used small, medium, and large. I have noticed now, I'm very sorry that I didn't put the output values. I forgot to add output values. I'm so sorry, now I have noticed. So this is also summary of fuzzification. We are giving linguistic terms. Those are the membership functions. Those are all triangular membership functions. Supervisor is, I am the, for example, we are the one, we are looking for the parameters base width, we are changing. So for extraction yield, which I have forgotten to show you its membership functions, it has, while each of them has 3 and it is triangular, trapezoidal membership function, 2 of them was trapezoidal membership function was used for the output, I mean the response.
Sorry,
yes.
Please speed up. You have 10 minutes.
Okay.
Okay.
Because please, the others are used so much time. You should warn them in the beginning.
Okay.
Okay. So fuzzy inference system is going to be used here. 25 rules developed. But at the end, we have reduced them to 13 rules because there was reputational rules. by using Mamdani means that you have many inputs, but you have single output system. It is going to give you the result. So in the fuzzy logic designer of Matlab, in the rule review sections, you're going to see the seed size, you're putting the values, your own values, and you're going to get the result here at the end. For example, for seed size, whole seed size, humidity, whole humidity, humid seed, and temperature is low temperature, and residual is opening is only 1/4 size. It is extraction yield was 33.3. Okay, just to compare our result with some linear methods, we also model with multiple linear regression to show that how fuzzy logic model is accurately finding the extraction yield. And this is the comparison value. This is so small, but I want to show here that actually we do 9 experiments. It is 27 experiments, 28 of them is the only for testing we use it. Those are the real data. I mean, those are the extraction yield, experimental values, and those are predicted values with multiple linear regression model and with the fuzzy logic model. So the comparison of the extraction yield predicted by the proposed model and multiple linear regression is going to give us R value is equal to R square value is almost 98, which is 98%, while multiple linear regression, the best model which he can do it is 82% regression of the experimental processes. It is included also what we call our test value. The last thing I will make in my conclusion, since you are hurrying up me, and it is experimental extraction process, which was giving 41.5%. In the unseen data, we have found by the fuzzy logic model, we have predicted as 40.9% extraction yield. So fuzzy logic is a very good method for participating in the some unknown data or modeling or optimization processes. So thank you very much. If any question, please ask us.
Thanks for your presentation. Dear participants, yes. Do you have any question about this article? Okay, no question. Thank you very much again for your presentation. I wish you success.
Thank you.
Thank you. Mr. Salma Aswat Abdullah, are you ready? Salma Abdullah is ready for presentation.
I am ready.
Oh, okay, sorry. Mrs. Salma Abdullah, you can start your presentation.
Let me share my slide.
Okay, please.
Hello everyone, hope everyone is safe and healthy. I'm Salma Aswad from Karabakh University. My topic is classification of VPN network traffic flow using time-related feature on Apache Spark. We have introduction, problem statement, contribution of study, methodology, result discussion, and conclusion. In introduction, I focused on classifying the VPN network traffic flow using the time-related feature on the Apache Spark and machine learning model, artificial neural network. Already half of today's internet traffic is encrypted using protocol like VPN or not VPN. This work shows that the curve is not sure. It's not sure because the analyzed dataset exposes features that allow for highly accurate classification without incorporating any payload data. And I used Matlab R2019A because to increase the demand of VPN network. As a purposed system is trained on 18 of dataset, while 20% is kept for the testing and validation with 10 cross fault validation as well as 15 epoch of the training.
Sorry, Mrs. Salma, you have 10 minutes, please.
Okay. As it is clear, that is the first work that introduced and analyzed artificial neural network and Apache Spark engine to implement the classification of VPN network traffic flow. In this process, I got accuracy for VPN classification by using ANN Apache Spark with 96.76%, and I got the accuracy for non-VPN classification with 92.56% by using ANN and Apache Spark. Packet level encrypted traffic classification. The remain packet can still be classified with high probability by guessing the application that use this flow. Internet is growing, no doubt about it. Communication between computers is also growing in form of email, instance message, remote control, and so on. This kind of service is used by companies, and these companies has different land and different location. The priority is having secure channel. These secure channels between LAN created a kind of global private network. There is no formal design for the advancement and classification of VPN traffic flow using time-related feature on Apache Spark with a framework of the big data.
Okay, Mr. Selma is offline. Mr. Mustafa Ajumali is ready. Are you ready?
Hello.
Hello.
Can you hear me?
Yes, I can
So,
hear.
can I share my screen now?
Please.
Can you see my screen now?
Yes.
Okay.
You
So
can
the
start.
okay, the video and the sound is clear.
Yes.
Okay. Okay. Hello everyone. This is Mustafa Al Jumaidi from the University of Tennessee, Knoxville, in the United States. And today I will talk about our work, that is the combined beamforming and waveform design using the mid-band frequencies for 5G and beyond networks. This work has been done with the cooperation of the authors listed in this paper or this presentation. First, I will talk about the motivation for this work. Then I will talk about why we need hybrid beamforming and why we don't use the cyclic prefix OFDM based waveforms, and we use other types of waveforms. Then I will talk about the assumptions and the system model for the beamforming and waveforms. Then we will talk about some numerical and simulation results and conclusions and future works. First of all, the mid-band frequencies or the C-band or the 3.5 gigahertz frequencies that we mean in our work, and the millimeter wave frequencies in the 24 gigahertz and beyond or above are now essential parts of the 5G and beyond networks. These high frequencies provide a huge amount of bandwidth that is underutilized so far, but they have some drawbacks or limitations because they are suffering from higher path loss and higher effect from the rain and atmospheric absorption, blockage, mobility, and all the other effects, which means that we need the beamforming to send narrow beams instead of the omnidirectional transmission in all directions to make these frequencies go further distances. Also, the OFDM, orthogonal frequency division multiplexing waveforms have been used for many years now, and they are great with a lot of benefits, but at the same time, they are also having some limitations that we are trying to avoid in our research. So now we are trying to combine the effect of beamforming and non-orthogonal, non-OFDM waveforms together and see their effect on the overall performance. So first of all, why we use the hybrid beamforming? There are many reasons to select the hybrid beamforming. There is basically the analog beamforming where we have only one RF chain, even if we have large number of antennas, which give us only a limited amount of spectral efficiency or utilization of the spectrum. On the other side, we have the digital beamforming where we have as many RF chains as the number of antennas, but it is difficult to build and it is not efficient from hardware point of view. And it consumes a lot of power, emits a lot of heat, and it is not feasible from like a commercial point of view. So the hybrid beamforming is considered as a combination or hybrid of the advantages of both types and avoiding the disadvantages of each of them. So here we can see that in the analog beamforming, we just use phase shifters in the analog part. In the digital beamforming, we do everything in the digital baseband. For the hybrid beamforming, we are just analyzing or performing the beamforming into two parts. Part of it in the digital side and part of it is in the analog side. That's why we call it hybrid beamforming. On the other side, and as part of our work, why we need new waveforms. Orthogonal frequency division multiplexing have been used for many years, and it is really simple to build, and it is compatible with fast Fourier transform. But as we said, it has some of drawbacks or limitations because it needs a lot of synchronization. It suffers from a high peak to average power ratio. Uh, uh, and it's sensitive to carrier frequency offset. It is sensitive to Doppler shifts, and it requires linear transmission circuitry, which reduces the power efficiency, and it suffers from the loss of efficiency, which is caused by the cyclic prefix. And as we said, it has a lot of out of band emissions. So a lot of new waveforms have been suggested to reduce or fix some of these limitations. For the beamforming, as we said, we are trying to build hybrid beamforming, and a lot of designs have already been suggested, like hundreds or even thousands of designs. In our design, we are just trying to use a simple method of matrix factorization by obtaining the fully digital beamforming matrix from the channel matrix, and then we just try to apply something called LU decomposition by just factorizing this matrix into two matrices that their product gives us the fully digital beamforming matrix. By doing so, we have been we reduced the complexity from big O of n cubic to big O of 2/3 of n cubic, and we got faster system and less hardware complexity or structure. And at the same time, we are achieving almost the same spectral efficiency that is achieved by the fully digital beamforming. This system has been suggested and published in the VTC 2019 last year. Basically, we are depending on this kind of methodology where first of all, the base station will send some preamble or pilot signals. The user equipments will send the feedback. By this time, the channel matrix H will be well known for the user equipment and the base station. After constructing H, we apply the singular value decomposition to get the fully digital beamforming matrix. After that, we perform the LU decomposition in the transmitter side and the receiver side. Then we construct our beams or the hybrid using the hybrid beamforming and the matrices that we got from the LU decomposition. And then the directional transmission between the transmitter and receiver through narrow beams will start. And we are trying to make sure that the beams of the transmitter and the beams of the receiver are aligned towards each other all the time. On the other side, as we said, the cyclic prefix OFDM that has been suggested for the 5G and before that in the 4G and a lot of other types of networks suffers from a lot of limitations. So now in the UFMC or the Unified Filter Multi-Carrier, we are suggesting some kind of a new design, which is shown in this figure, where it has a lot of advantages over the OFDM, where we for each resource block there has its own filter or TX filter, and we have some kind of zero guard bands between each successive inverse fast Fourier transform, and all of these will reduce the out of band emission and also reduce the intersample interference. By using or combining the hybrid beamforming using the LU decomposition and the universal filter multi-carrier waveform, we tried to build some kind of this system where we compare the performance of the system when we use cyclic prefix OFDM and the performance when we use the UFMC. This is some kind of diagram to show the experiment where first we set the parameters for the system for the simulation system. Then we set the parameters for the 5G environments. We use two types of channel models, the additive white Gaussian noise and the extended pedestrian A model with different features and parameters. Then we use the combined beamforming and waveform by using the two types of beam waveforms and compare their performance. And we use the hybrid beamforming design that we talked about. Then we do the simulation and using the Matlab and LabVIEW, and then we calculate some numerical results to show us the benefits of using the UFMC over the cyclic prefix OFDM and the benefit of using beamforming for MIMO systems. This table shows us some of the simulation parameters that we used in our system. As we can see, we use the frequency band 3.6 gigahertz. The bandwidth is 10 megahertz, and resource blocks is 50, and the others as shown here. And of course, there are more details in the paper. First of all, we tried to compare between the 1x1, which is SISO, single input, single output antenna, using the OFDM, and we see the throughput of the system using the additive white Gaussian noise channel model, and comparing that with the other MIMO systems, 4x2, 8x2, 2x2, and 6x2. And we can see that the more MIMO we have, for example, here in the 8x2, using the UFMC, we will have like better and superior throughput compared with the smaller MIMO structures, and this is thanks to the UFMC and the beamforming combined. Then when we change the channel model to the EPA, and there was we expected to have like a degradation in the achievable throughput, but we saw that the throughput remained the same and even got better in some situation. Again, thanks to the UFMC and the beamforming, where here we can see that for the 1x1 SISO, it achieves specific type of throughput, and the more or the bigger MIMO system with the beamforming and the waveform, that is UFMC, we can achieve better throughput. Even for mobile users in the pedestrian, extended pedestrian I model. These are also some additional results that, and of course, there are some details about that in the paper if someone is looking for more details. Finally, for conclusions and future work, we saw that here we tested the effectiveness of using both of the beamforming and different waveforms. And we saw that the new waveforms, that is non-OFDM, can achieve better performance when combined with the beamforming or the right design of beamforming. Different combinations of MIMO, beamforming, and waveforms have been tested for realistic environments, realistic channel models. This work also can be extended further for higher frequencies in the millimeter wave band from 24, 28, 39, and even higher frequencies that are now part of the 5G and will be even part of the 6G and beyond. Also, the effect of serving more than one user at the same time, or the multi-user massive MIMO, is also a good direction for future investigation. And this is some of the work that we are working on right now. Finally, thank you for listening. And if there is any question, I will be happy to answer them.
Thanks for your presentation. Dear participant, do you have any question about this article? Okay, no question. I wish you continued success in your career. Hope to see you.
Thank you. Thank
Mr.
you. Thank
Mustafa.
you so much. Thank you. Thank you.
Okay. Ms. Selma, you are online.
Yes, I am here. Sorry, my internet was problem, and now it's
okay.
Ready.
If you are ready, you can start your presentation.
Okay.
Continue your presentation.
The methodology, the method that I use I use it in this study: artificial intelligence, machine learning, artificial cognition, and deep learning. In this study, we'll discuss smart system in general, and that include AI, ML, Apache Spark, and ANN will be used later in the work. For this purpose, source of programming language being used is Matlab on Matlab R 2019 platform with both CPU and GPU utilization. In general, ANN is a machine that is used to model that way for brain performance. Neural network are the artificial imitation of the human nervous system. This chart explains my methodology. We start with a data set, choose ANN, then operate the Apache Spark engine. We try to manage VPN cluster, train and validate the system. We either get the VPN classified or we return the system using a new parameter. If the system works, we plot the error bar, separate the VPN network sentiments, then we get the post-processing phase, and the experimental results are shown. I got my dataset named as CIC Darknet 2020 from an open source repository. In my study, I focused on Darknet file only. The dataset file reflects how network nodes function. I used small dataset because I wanted to compare performances, as smaller dataset means less time for experiments. Architecture of Apache Spark. It consists for driver, worker, cluster manager, and executors. driver is responsible to find all links and content in a given list of domains or detection network. Worker, this step may be optional if the goal is to build the search engine or just to work as a slave for the driver with the content from the prior step. Cluster manager. It store and manage the network data using machine learning algorithm as well as the link in the gathered information. In addition, it may manage different indicates. Excluder. It is the step where network data gathered is executed with specific information from the cluster manager by the worker node. Exactly where the information is extracted, for example, link and time related features. To build a machine learning model that can predict the right next hop when the related contact graph data entry is plugged into it, application types of VPN and non-VPN. I used these 6 application and traffic types of the CIC Darknet 2020 dataset. Email, chat, streaming, file transfer, VoIP, peer-to-peer. Email contents for email, Gmail, SMPT, POP3, IMAP. Chat is contents, for example, ICQ, AIM, Skype, Facebook, Hangouts. Streaming like YouTube, Netflix, Spotify, VIMU. File transfer like Skype, FTPS, SFTP. VoIP like Facebook, Skype, Hangouts, and VoIP Booster. Peer-to-peer like uTorrent and BitTorrent. Training model. That is the testing step where the ANN training model will be tested. The test will be implemented using the new contact graph dataset that the neural network has never seen before. Using that new dataset will be a fair evaluation for the proposed space VPN ANN routing solution with Apache Spark. Now, in this 2 figure, we have contradictory result concerning number of layer. In this figure, when the number of layer is increased, we get the higher accuracy. And in second figure, when we do validate if that in the number of layer is increased, we get the less accuracy. And these are the results. The experiment will include testing the effect of changing the parameters that are required to build ANN. And also, additional components will be changed to check the difference in the network behavior. During the process, I used Matlab R2019A Windows environment on 12 GB RAM and 2.4 GHz Intel Core i5 10th generation. Rather than ANN being a mathematical or experimental effort, we can also say fine-tuning the neural network and customizing it is becoming a type of art. This experiment will try to find a solution that is potent enough, that is by using the least possible resources, giving the best accuracy, less loss, and less training time. This table analysis incorporated only non-VPN traffic. Result of the dataset analysis based on flow consisting of the number of packet and unambiguous packet, while the fraction of Anki flow is relatively low, 91% of the packet can be unequally associated with one application. Only 46% of the non-VPN flow in the dataset are unequal and could therefore be classified as belonging to one application. All other flow are used by the list two application. Only a few applications like YouTube or Spotify could be identified with high accuracy based on a given flow. This
Sorry, Mrs. Selma, be quickly because the other sessions will start.
Okay.
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 At 7 o'clock.
Okay. This table analyzes the both VPN and non-VPN traffic result. Result of the dataset analyzed based on flow consisting of the triple source port, destination port, and used protocol, while the fraction of unqueued flow is relatively low. 93% of the packet can be unequally associated with one application. This analysis incorporated both VPN and non-VPN traffic. And the results are shown in these details in this figure. First figure, the detection precision of VPN time-related feature using ANN and Apache Spark engine. The classification precision of VPN time-related feature using ANN and Apache Spark engine. The classification of major time-related VPN feature using the ANN and Apache Spark engine considering all processing data at 25 epochs. The classification of major time-related VPN feature using the ANN and Apache Spark engine considering all processed data at 15 epochs. And the last figure, the categorical feature classification of VPN and non-VPN feature with respect to overall classification precision, when VPN classification precision stand at 96.76%. However, the non-VPN stand at 92.56%. In the discussion, we have two main approaches, which are statistical based ANN and behavioral based ANN. And both approaches use one-dimensional ANN on a single packet. Okay, this two figure compare my result with other result. I used the Darknet 2020 data set, and this is my result. And the other result, it is ISCX VPN 2016 data set. And this table also compared my result with other result, and we showed the application and traffic comparing the result of the table CNN result, and two shows a correlation between the predictive performance of the proposed model and the amount of unambiguous packet that can be associated with each application. The application with low F1 score are also the application that have a very low percentage of unambiguous packet, namely AM, chat, and ICQ have the lowest F1 score, and are also the application with the lowest percentage of unambiguous packet, followed by email. It is unlikely that our approach actually learned how to find patterns in the encrypted data. It is work likely that the
Okay, there is a mistake. Maybe internet is down. Miss Selma, are you okay? Mr. Tanmoy Sarkar, are you ready for your presentation?
He already presented.
Okay, sorry, Mrs. Tanmoy Sarkar. Sorry. You can start your presentation, please. You can share your screen.
So, who are you mentioning about? I also presented, so me and Tanmoy are done at the very beginning.
Mrs. Tanmoy Sarkar.
Mr. Tanmoy already did the presentation. He was the second speaker.
Okay, okay. You
and
can
this is
start.
Tanzania Hilali. I am also done as the first speaker.
Okay, okay. You can start your presentation.
Sorry, I did it at the very beginning. So I presented already.
Okay. Evet, Mrs. Selma returned the session. Mr. Selma, Mrs. Selma, welcome.
Hello, welcome. I'm so sorry, my internet is...
Okay, not at all. Not at all. It's not problem for me. Please continue your presentation and end it quickly.
Okay, I will conclude. Now, what will happen in the future is a huge advantage. It gives us the power to make early discussion. The only task that the node is required to do is to forward the bundle to the right next hop when the time comes and it appears inside of contact. Applying the proposed artificial neural network will prevent unnecessary processing as well as flooding found in common VPN network traffic classification, as the proposed system is trained on 18 of VPN network traffic classification. On 18 of dataset, while 20% is kept for the testing and validation with 10 cross-fault 10 cross validation as well as 15 efforts of bringing to the best of our knowledge. This is the first work that introduced and utilized artificial neural network and Apache Spark engine to implement the classification of VPN network traffic flow. The categorical feature classification of VPN and non-VPN feature with respect to overall classification precision, where VPN classification precision stand at 96.76%. However, the non-VPN stand at 92.56%. The ANN plus Spark Engine technique outperforms the convolution neural network in comparison with stacked autoencoder network on CIC Darknet 2020 and ISCX VPN 2060 respectively. And this is the reference.
Okay. Thank you for your presentation.
Thank you so much. Any question?
Dear participant, do you have any question about this article? Okay, no question.
Okay, thank you so much.
Thank you very much again for your presentation. I wish you success. Hope to see you. Good evening. Evet. Deep learning-based Bangladesh license plate recognition system. Tanmay Sarkar. Except this article, all participants present their presentation. All participants, I wish you continued success in your career. Hope to see you. Good evening.
Good evening, sir. Okay. Thank you.
Thank you.